folks, welcome to section 9.8. We're going to look at quadratic inequalities. Now 9.8 is out of the intermediate algebra book. You can see the page numbers aren't quite in line with what we've been doing, and you can see these homework numbers are definitely not in line. This particular book doesn't reset the homework problems at number 1 for each section, they just continue them. So you actually have number 363 to number 387. All right, so we're going to solve quadratic inequalities in this section. We've taken a look at linear inequalities in the past, absolute value inequalities, but let's focus in this particular section on quadratic inequalities. And when we get to a different section in this intermediate algebra book, we're going to look at rational inequalities. So for today, no fractions. Heading into a future section, we're going to have fractions and an inequality symbol. And we're going to solve these one of two ways, either just looking at the graph or doing some algebra. And I will say I'm happy to look at the graph, and I think these are fun, but most of the time when I'm solving inequalities, whether they're quadratic or linear or rational, whatever, I tend to do them algebraically. So I'm also going to introduce you to these things called sign patterns. All right, and that's pretty much how we solve inequalities. Or how about, maybe I'll say it's my favorite way of solving inequalities. And these sign patterns are going to show up all over the place in calculus. Okay, so when you have a quadratic inequality, it really means you have a quadratic expression like ax squared plus bx plus c, and you have an inequality symbol, right? So you either have less than 0, less than or equal to, greater than or equal to. And we're going to solve these, like I said, two ways, graphically and algebraically. We want to connect our picture to the actual work we're doing. Okay, so let me scooch this up a bit, and we'll start to look at this really just through the graph lens initially. All right, so if I were to graph this parabola, right, we've talked about our basic toolkit functions. Anytime your highest degree of x is a 2, you've got a parabola, right? And if a is positive, you've got your toolkit, y equals x squared kind of graph. And then if a was negative, let's say this was negative x squared, you've got your upside down graph, right? Now you might have some shenanigans, the bx plus c, that shift things up, down, left, right, all that fun stuff. But you know what your basic graph looks like. So when I ask you something like, when is ax squared plus bx plus c less than 0? Right? When is this thing less than 0? When is your parabola less than 0? If we want to kind of translate that into a graph sense, right? When is my function less than 0? That translates to when is my graph below the x-axis? All right, so we're going to associate less than 0. If you saw that less than 0 here, and you're being asked to solve this inequality, you're going to look for where is your graph below the x-axis. And I want to mention that when we start to write up these intervals, right, we're only going to concern ourselves with the x-coordinates. And we'll go into this, but only use x-coordinates in intervals. All right, now we may use parentheses or brackets depending on if you had a less than or equal to, because keep in mind, if I asked you when is ax squared plus bx plus c equal to 0, that's actually code for when is your graph on the x-axis, right? So less than 0, your graph is below the x-axis. Equal to 0, right? Those are our x-intercepts. That's when is your graph on the x-axis. And on the flip of that, if we saw when is your function, or in this case, when is your quadratic expression, when is that greater than 0, when is your function positive, that translates to when is your graph above the x-axis. So we want to break our graph into 3 different parts, right? When is it below, when is it on, and when is it above the x-axis. So those are kind of the 3 graphical lenses, or the 3 graph categories we're going to look at. And then we're going to write up our intervals using only x-coordinates. And we'll discern parentheses or bracket just based on did I have a less than or equal to, or greater than or equal to. So now if I scooch this up and we see these graphs coming, give me a moment to get this scooched up. All right, we see these graphs coming. You can see here, if I start on my happy, I call them happy parabolas, right? This is happy, it's facing up. It's kind of like a happy face or happy smile, sad face here, right? Upside down parabola. But you can see here, my graph is above the x-axis and my graph is above the x-axis here. So on the ends for this particular graph, right? above, above. So I would say f of x is greater than 0 here, and f of x is greater than 0 here, right? So in two different intervals, it was above the x-axis. So I would say this was above from negative infinity to this x-coordinate, right? And then this second x-coordinate to infinity. That's where my graph was above. It was on the x-axis here, right? You can see my two intercepts. That's where my graph was equal to 0, right? Greater than 0, equal to 0. And then you can see up in here when it was below, and I know it's a little grayed out, but that's when your function is negative. That's when your function is less than 0. All right? So this particular graph went above the x-axis, on the x-axis, below, on, above, right? That's what our graph looked like. And on the flip of it, right, here my graph went below, on, above, below, on. And I want you to hear I'm moving left to right. That's how we typically do with our x-axis. We always go left to right, low to high. So my graph went from being negative to 0, then positive, back to 0, and then negative, right? We went below, on, above, on, below, as I move left to right. Okay, so we're gonna go ahead, we're gonna take a look at a couple of these quadratic inequalities, and we're gonna do it through a graph lens. So typically when I think about my graphs, I think good points to find with a parabola, I think x-intercepts are a great place to start. Maybe you want to do a y-intercept, and maybe you want to find the vertex. So let's consider all of these as we start moving forward on, oops, and you'll have to forgive my camera. It gets out of focus when I switch pages like that. So let's go ahead and take a look at example 1, and we're going to do this graphically. So here is my quadratic inequality, okay? And if I want to solve this graphically, what I really want to think about, I'm going to start with finding x-intercepts. All right, so I'm going to find some important points or some interesting points on this graph. So if I think about f of x being x squared minus 6x plus 8, and I want to find x-intercepts, that means I want to set my y-coordinates to 0, right? So at this point, if I want to solve when is x squared minus 6x plus 8 equal to 0, you can factor or use the quadratic formula, or you could complete the square. I'm going to go ahead and factor only because it's the quicker way. But if you're not a big fan of factoring, then keep in mind you can always use quadratic formula. But this is ultimately x minus 4 times x minus 2, which is equal to 0, right? And then I use the zero product property. Oops, let me finish writing that out. That should say x minus 4 is equal to 0, or x minus 2 is equal to 0. So I'm going to get x equaling 4 or 2, right? So there's my two x-intercepts. If I wanted to, I could get a y-intercept. That might be a good trait to have. If I want a y-intercept, that's when I actually want to plug 0 in for x, right? So if you want the x-intercept, you let y equal 0. If you want a y-intercept, you let x equal 0. You always use the opposite number, right? So if it's an x-intercept, I'm going to let y equal 0. If it's a y-intercept, I'm going to let x equal 0. And when I play this out, I get what? 0 squared minus 6 times 0 plus 8. So I see I've got that, oops, that's just the number 8. All right, so I've got my two x-intercepts at 2, 0 and 4, 0. And then I've got a y-intercept at 0, 8. Another point that could be interesting and helpful for us would be the vertex. So let me just put a little separation in here. Anytime you want to find the x-coordinate of the vertex, let's say I want to find the vertex, right? It's always x would be negative b over 2a. Now again, you don't always have to find all three of these, but if I'm solving something graphically, it's never a bad thing to just find those traits, right? Those important points, those interesting points on the graph. Intercepts are pretty interesting. For parabolas, a vertex is pretty interesting. So if I do negative b, that would be a negative of negative 6 over 2 times 1, right? And when I get that number, negative of negative 6 is 6. 6 over 2 is 3. All right, so there's the x-coordinate of my vertex. If I want the y-coordinate, let's plug 3 back in. So 3 squared minus 6 times 3 plus 8. All right, so what do we have here? We have 9 minus 18 plus 8. So when I crunch that, I'm going to think of this is 9 here, right? Positive 9 plus 8 is 17, and 17 minus 18 is negative 1. So if I want to go ahead and write my vertex, that is 3 comma negative 1. So at this point, I have a number of ordered pairs I can make. So let me go ahead and graph what I've got. All right, let's just take a look at what we have. Oops, let me make a slightly better graph. All right. All right, I'll put my labels of X and Y. And when I take a look at my numbers that are involved, I don't have, looks like the highest Y value I'm taking a look at is 8. So let me scale these up by 1. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm gonna have my Y-intercept up there. If I look at my X-intercepts, they're 2 and 4 respectively. And then my vertex is 3, -1. And since I know this is an upward facing parabola, right? It's a happy parabola. I can make that graph. It looks something like this, right? So there's my graph. That's step 1, right? Just get the graph of your quadratic. And now let's kind of look at this inequality symbol. It means, or it's saying less than 0. So graphically, I want to look, where is my graph below, strictly below the x-axis, right? Not on, not above, but below. And I'm going to grab my highlighter and we're going to see, let me get this here, that my graph is below the x-axis here. Right? That is the only time it's below. And what I want to do is I want to write up the x-coordinates here, right? When you're talking about when is your inequality less than 0, we're only caring about the x-coordinates. All right, so if I remember this x-coordinate, this was what, 2? This was 4. So if I want this interval, right, then I want to say x is going to be anything between 2 and 4. And that is ultimately going to be my endgame answer. All right, thanks so much. Bye.